Okay, balancing of chemical equations. We know that a chemical equation is the symbolic representation or the shorthand representation of a chemical reaction, wherein um, the substances are in the forms of symbols or formulas, and we have to take note that the parts of the chemical equation wherein on the left side we have the reactants. Okay, so the substance undergoing the reactions are the reactants, and on the right side are eventually the products, and these are the substances being generated or being produced after the reaction. So if there are two or more substances in the form of elements or compounds, their formulas or their symbols will be separated with the use of a plus sign. Okay, so and that is also true for the product. So if you are producing two or more products, then the symbols are and the formulas for these substances will be separated with a plus sign. Now, to separate the reactants from the products, or to distinguish reactants from the product, we are using an arrow to denote that the process flow is from the reactants going to the product. Okay, so we have the parts, and we also have the coefficients, which are big number being placed immediately before uh, each element or each formula or each symbol. Okay, so again, if the coefficient is 1, it may be omitted and it represents 1 mole. Okay, so a chemical equation that is balanced will have the same number of atoms for each element, represented both in the product and in the reactant side. And when we say balanced chemical equation, we are actually following the law of conservation of matter. Okay, so we have here the parts of a balanced chemical equation. So the number written before each symbols or each formula of the substances that was involved in the chemical reaction is known as the coefficient, or this represents the number of moles involved. Okay, so on the left side, with the basis of the arrow, so the left side of that arrow are the reactants, and on the right side of that arrow are the products. So if there are two or more reactants or products, they should be separated with a plus sign. Please take note that originally there are subscripts, small numbers written each and after, depends on the formula or of the symbol of the compound. So this should not be altered during the balancing of equation, kasi the subscript is actually the identity of the substances. So if you're going to manipulate, if you're going to remove the subscript, then therefore the identity of the substance involved will be altered. So what we are only manipulating during the balancing of equations are the coefficients. The subscript will retain as is. Okay? So, also, meron ding mga symbols for the physical states of matter for each substances involved in the reaction. So, say for example, for carbon dioxide, with the G there represents that it's in gaseous form. So, water with an L represents that it's in liquid form. And you have here C6H12O, okay, with the uh, O6 rather. C6H12O6, or that is the glucose, possibly glucose. Okay, so this could be in solid form. And again, the oxygen is in gaseous form. So this small subscript here written after each formula is actually the state of matter. Okay, so that's for the chemical equation. Now, for the balancing of chemical equation, there is no exact steps on how you balance it. This is actually a trial error method wherein you have to get the same number of element in the product side as well as equal to the product side. So this is trial and error. Just manipulate the coefficients, not the subscript, to balance them. So again, I'll repeat, we are inserting. We're going to insert numbers here known as the coefficient before each formula or symbol of the substances involved, but not do not alter the original subscript. Remember that subscript is the small number present in each formula. Okay, so what we have to do is we have to know what are the elements that comprises the chemical equation. So as you could see, carbon, hydrogen, and oxygen are the elements that could be both found in the reactant and in the product side. So counting the atoms of each element in the reactant side, carbon has 6 because of the subscript 6. Hydrogen will have 6 and oxygen will be 2. Okay, those are the original count. And on the product side, we have carbon to be 1, then hydrogen is 2 coming from the water, and oxygen, since there are two sources of oxygen, 2 coming from the carbon dioxide and 1 from the water. So the total of oxygen in the original equation is 3. So looking at it, the number of each element, both in the reactant and product side, are not equal. So we have to put coefficient. So coefficient are written after, written before each formula. Please do not change the subscript just to balance it. So again, we are not manipulating the subscript. Do not change the subscript, otherwise you will be changing the identity of the substance. What you have to do to balance it is you just have to insert numbers before each formula. Okay, so if we choose carbon to be our first element to be balanced, since originally it has 6, so we just have to put 6 before the carbon dioxide. Kasi dito sa carbon dioxide, iisa lang siya originally. Okay, 1 lang siya kanina doon. Okay, so 1 lang siya kanina. We put 6, and take note that if we're going to put 6 here, that coefficient will be multiplied to the subscript, original subscript of the element. So that would be 1. So since walang nakasulat na subscript kay carbon dun sa carbon dioxide, of course, we know that that's 1. So 6 times 1 is 6. With that coefficient, carbon now is balanced. But doing so, of course, that 6 is not only for carbon, it is also for oxygen. So since oxygen has 2 atoms in the is 2 carbon atom in the carbon dioxide, so that coefficient, that inserted 6 coefficient, should be multiplied to 2 for the count of oxygen. So for this case, with the balanced carbon atom, oxygen now, from being originally 3, with that 6, so 6 times 2 is 12 plus 1, so this time it's 13. So still, hindi pa rin siya balance. Pero okay lang yan, mag-move tayo sa next element. Okay, so with that, so andito na yung 6 kanina, so okay na si carbon atom. Hindi pa masyadong okay si oxygen. Let's go to the hydrogen. So with hydrogen, kailangan nating mabalance yung 6 and 2 kanina. So what we have to do, we have to think of a number that should be multiplied to 2, and makakukuha natin yung 6, and that would be 3. So doing so, 3 times 2 for hydrogen subscript is 6. So with that, balance na si hydrogen. Pagtingin natin sa carbon, ganun pa rin naman, 6. Hindi siya naapektuhan nung coefficient of 3 for water kasi wala namang carbon component dito. So still, carbon remains to be balanced. Hydrogen is now balanced. Okay? With the 3 coefficient, of course, the oxygen in the water could also be affected. So that 3 will be multiplied to the subscript of oxygen, so 3 times 1. Remember that 6 times 2 is from the oxygen in the carbon dioxide. So the total would be 15, because 6 times 2 is 12 plus 3 times 1 is 3. So that's 15. Okay, so as you can see, carbon and hydrogen is now balanced with the coefficient of 6 and 3 for carbon dioxide and water respectively. But for oxygen, medyo dumami siya dito, 15. So we have to think of a number that when multiplied to 2, kasi nga 2 originally dito, would become 15. And that would be a fraction of 15 over 2. Okay, so with that, with this 15 half times 2, so 2 will be cancelled, we're going to have 15. Okay, so we could put the 15 2 there just for representation. But we have to take note that all coefficient in fraction form should be multiplied so that it would be represented in whole number. Kasi kailangan lahat ng mga coefficient natin ay whole number. So we have to think of a number that when multiplied to 15 half would become a whole number. And of course, syempre, para makancel na yung 2 yan, you multiply it by 2 and that will become 15. But if you're going to multiply the fraction coefficient with this multiplier 2, you also have to distribute, or you should multiply all the coefficient for each substances involved in the equation. So that 2 is not only for 15 half of oxygen, but also for the coefficient of C6H6, or this might be benzene. So that would be, kaya nagkaroon na tayo ng 2 doon. Okay, so that would be multiplied to 2. So, ayan na siya. So, the 15 half, the 2 had been cancelled. So, naging 15. The 6 for the carbon dioxide has then become 12. And the 3 has then become 6. So, if you're going to count, carbon now will have 12. Okay, both in the reactant and product side. For the hydrogen is still 12. Okay. For the oxygen, this is 30. Okay, in the reactant side. In the product side, 12 times 2 is 24 plus 6 times 1 is 6. So 24 plus 6 is still 30. So all in all, these coefficients are now the simplest coefficient for this chemical equation. So this is actually a combustion reaction of benzene or C6H6. Okay, now you might say that there will be a point that you're going to come up with a very large number, and if you're going to count, balance pa rin din naman. But meron pa tayong isang rule that all the coefficient must be expressed into its simplest form. What I mean is, so say for example, um, we had we had derived a while ago that this is the balanced coefficient. But say for example, you come up with 20 C6H6, 150 moles of oxygen, producing 120 moles of carbon dioxide and 60 moles of water. As you could see, parang balance din naman sila. Balance pa rin. May count mo yung carbon, hydrogen, and oxygen for each side, reactant side and product side. But even for a fact that the number of carbon atoms, oxygen, and hydrogen here are all balanced, we are not going to accept this one because the 20, 150, 120, and 60 could still be reduced into the simplest form. So again, even for a fact that these are balanced, the coefficient is not expressed in the simplest form, so therefore this could not be accepted. Okay, so that's the trial and error, or the steps in balancing a chemical equation. Okay.